Okay, so one of the tough things about graphing trig functions is coming up with those x-axis labels. It can be a little tricky because there's a lot of usage of adding and subtracting fractions. So I got a function here that we're going to go ahead and graph, and so we just want to figure out where the start and end points of this graph are. So we're going to set up our inequality here, our compound inequality. And a normal graph, a typical graph, would go through 0 and 2 pi, but this 3 times the quantity x minus pi over 15 is obviously going to have an effect on things. So to figure out what that effect is, we just solve this compound inequality. Start out by dividing by 3, and so when we divide everything by 3, we're left with a 2 pi over 3 over here, and now we're going to add pi over 15 to both sides, to all the sides. And so here comes our first fraction. So maybe off to the side here somewhere, we're going to just on scratch paper off to the side, we take 2 pi over 3 plus pi over 15. Well, in order to add these two things together, I got to find common denominators. So I'm going to multiply by 5 over 5. And so 10 pi over 15 plus pi over 15, that gives me 11 pi over 15. Okay, so there's my start and end point. And so when I go to graph this, this thing is going to start at pi over 15, and we're going to do one cycle just to keep it simple. And it ends at 11 pi over 15. Well, so now I got to fill in all these values starting with this midpoint right here. And so I got to find the halfway distance between pi over 15 and 11 pi over 15, which can be quite confusing. So what I want to do is, let's scroll down just a little bit here, and before we figure out this midpoint, let's just take a generic number line. And let's just say this is a 1 and this is an 11. We'll keep it simple. If I wanted to find the halfway point between 1 and 11, I can certainly do the little hash marks on both sides and figure out where they meet in the middle. But we're just taking an average, right? We're trying to find out the middle here. So to figure this out, I can take 1 plus 11 and then divide it by 2. Well, that gives me 12 over 2, which is equal to 6. So the halfway point between 1 and 11 is 6. And when we're graphing trig functions, we're now going to have to find another halfway point. So I'm going to use the same process. I'm going to take 1 plus 6, we're just figuring out the average, and divide it by 2. It's the same thing as multiplying by 1/2. Dividing by 2 is the same thing as multiplying by 1/2. So that's 7 halves. And for the 6 and the 11, I can take 6 plus 11, divide that by 2, so that gives me 17 halves. And so if I were to split this up, this is what it would look like. Well, now we're going to do the same thing, but we're dealing with, instead of just 1 and 11, we're dealing with 1 pi over 15 and 11 pi over 15. So the process is the same, it just takes a little bit of extra time. And so again, maybe off to the side, I do some scratch work, and eventually you might be able to do this in your head. But I'm going to take pi over 15 plus 11 pi over 15, which gives me 12 pi over 15. And I know that can be reduced, but we're just going to hold off on reducing it for now. And then I'm going to divide it by 2. Same thing as multiplying by 1/2. Dividing by 2, multiplying by 1/2. Same thing. So that gives me 12 pi over 30. Reduce each of those by 6. Not 6. Reduce it by 6. So that gives me 2 pi over 5. So my halfway point here is 2 pi over 5. Well, I'm going to do that same procedure to find this halfway point. So I'm going to add these two values together, pi over 15 plus 2 pi over 5. Pi over 15 plus 2 pi over 5. I need common denominators. I'm going to multiply this by 3 over 3. So that gives me pi over 15 plus 6 pi over 15, which is 7 pi over 15. Take half, divide by 2, multiply by 1/2, same thing, and I get 7 pi over 30. Maybe you want to stop the tape and see if you can figure out this one on your own, and then come back and verify your answer. To save a little space, I'm going to have to erase some of this stuff over here. So let me get rid of this. Alright, and so now we're working on finding the halfway point between 2 pi over 5 and 11 pi over 15. I'm going to add them together. 2 pi over 5 plus 11 pi over 15. Eventually you'll get pretty good at this. You'll be able to do it in your head. 3 over 3. So this gives me 6 pi over 15 plus 11 pi over 15, which is 17 pi over 15. Take half of it, divide by 2, same thing, and I get 17 pi over 30. Now, there's something interesting going on here. When we graph this thing, and we can just, sketch in our graph right here that this video is not so much about graphing as it is just figuring out those values. So the graph would look something like that. But let's say we needed to continue this thing, and we wanted this thing to keep going. And so I want to come up with the next hash mark there. Well, there's always going to be a pattern here, and it's just a matter of whether or not you can find it. I always look for the highest denominator. So the highest denominator is a 30. And so what that means is I can write all of these fractions as a common denominator of 30. Right? So to get from 5 to 30, I have to multiply by 6. So it's going to be 12 pi over 30. That's 17 pi over 30. Here I got to multiply by 2, 22 pi over 30. And you can see now that to go from one fraction to the next fraction, all I'm doing is I'm adding 5 pi over 30 to each one. 7 plus 5 gives me 12. 12 plus 5, that gives me 17, and so on. So if I understand that pattern here, all I have to do is add a 5 pi over 30, and that gives me 27 pi over 30. Now that can be reduced, right? So perhaps we should write 27 pi over 30 here, and then we can reduce it by, I guess we reduce it by 3, so that gives me 9 pi over 10. And that's the way it works. And then you can just keep the pattern going once you find it. You have all sorts of options here when you're doing this, but that's something that might help.